Okay, so hi all. This is a talk about using in-browser free and open source software tools for science communication and evidence-based environmental policy. So it's a really short talk that covers up a lot of the discussions that have already taken place with other talks. So it's sort of also a supplement to those talks. At this time, this is also in some ways a call to action for doing better science communication, and also it is um, a means to like it's also a rambling for me for just spreading the word about the projects that I maintain. So here's a little bit about me. I am a software engineer at Quansight, and I usually like doing Python packaging and distribution. I like the documentation, but recently my interests have also been piqued by interactive and numerical computing, and I am involved with a few packages and libraries, in specific Pyodide and Jupyter Lite, and I'm also a member of other open source organizations. I'm focused on scientific Python. So, just to get to the crux of my presentation, what I want to talk about here is that we are doing science communication in a very poor manner, in a sense that there are a lot of structural barriers to science communication, whether that's, let's say, monetary barriers. Let's say you don't have the right level of funding required to do proper science communication, or let's say there are, in these cases, ideological barriers. So even though you are like scientists, or even though you have like so many people who are reading about science, you still commit to not doing anything about superstitions. And then this is also something that ties into stubble burning. For example, stubble burning is a highly politicized issue in India at this time, especially in because of how it is perceived to cause pollution in New Delhi. And it's said to originate from Punjab and Haryana. And what I would like to emphasize on this aspect is that stubble burning has actually reduced by 71% in the last 5 years since the pandemic happened. And as this time, it contributes only around 0.92% of all the air pollution indicators in the entire, basically all over the year in New Delhi. So all of the air pollution that you're seeing in New Delhi is being caused by vehicular emissions and emissions from industries. So you can read the report for getting to, like, you can read this report to know more about it. Also, it's what this does is that it overshadows real issues that we should be thinking about. For example, at this time, Delhi's air is poisoned with mercury at a level that's much higher than other cities, and even in other cities, it's um, it's much higher than what the safe standards should be. So what this usually does is that it derides data driven policy making, or basically it leads to the lack of data driven policy making, which means that resources are misdirected, which is why, like, if you have let's say the media talking about issues that are not pertaining to that don't pertain to such problems, then vulnerable communities are disproportionately affected. So and also this means that people think that scientists do not do anything, because at this time scientific institutions are basically so public trust in scientific institutions erodes as a result, because there's no solution to air pollution if you're not tackling the right problems. So just to get back to the technical elements of my talk, there's this project called Pyodide. It's a port of CPython, the Python programming language, to WebAssembly. And basically, it supports a lot of scientific Python packages. These fundamental packages, which I've listed here, these allow you to use various other packages in, let's say, the geospatial area. And there's like hundreds of packages and libraries compiled using the Imscript and compiler toolchain. And you can install a lot of these packages as Pyodide wheels, which is basically the format that's used in Python packaging to install binaries. So similarly, this has been talked about by Arjun in his talk quite to quite an extent. This is Jupyter Lite. Jupyter Lite is also a project which is basically WebAssembly powered Jupyter that runs inside your browser. It's reproducible by design because all of the code data and all of your configuration is stored at a hosted static location, and also that it is by extension using Pyodite for as the Python driver inside, as the Python kernel inside for your Jupyter environment, which supports log files by default. So as opposed to Jupyter Hub, it is deployable using static website hosting providers, so whether through GitHub pages, Cloudflare pages, GitLab pages, and so on. This is what I feel is trying can be used to establish a new brand of interactive computing based on small data. And what I mean by small data is particularly data that is smaller than, let's say, 1 GB that you can operate on within the uh, confines of a browser, which means, let's say, being able to run through some basic data analyses on CSV files or Parquet files, or basically on, let's say, GeoJSON files. And basically, my talk is also a call to action in this regard, using FOSS in browser tools to be able to use channel resources towards science communication. So there are a bunch of apps that use Pyodide and are based on the Jupyter Lite ecosystem. So there's Voicey. Similar to Mercury, the tool that Kriyanshi mentioned is for basically creating web apps from Jupyter notebooks. This is it can be used to create apps that are run statically inside in the browser. And similarly, there's Dataset Lite that also uses Pyodide for small data use cases. And then there's Panel, which is like a very heavy duty application for data exploration and dashboarding, but it can also be used with Pyodide. So there's a lot of new stuff with Pyodide. So right now, we in this year have enabled new packages, not us, but a lot of our contributors. So you can now establish much more refined standards for high performance use cases. So you can use small data even better nowadays using PyArrow, DuckDB, and Polars. Similarly, improvements to the WebAssembly standard across browser conventions means that, in particular, JavaScript promise integration is now available. It is the default in Chrome 137. This allows you to run synchronous Python code with asynchronous JavaScript web APIs. And this allows you to work with a lot of packages in the geospatial area to now be able to work on basically what is the web loop. The web loop is where is the main thread event main event loop that's Pyodide's equivalent of the standard conventional thread loop. So thanks to all of our contributors for their hard work, and to you, the viewer. It's a talk about. Consider this as a talk about using in-browser frameworks to build civic tech initiatives, and also to it sort of tries to reiterate that a lot of data work nowadays does not require HPC workflows, especially if you're working on small data, because there's like in-browser tools that you can use without provisioning a server. And WebAssembly, I believe, can be a first class format for in browser scientific workflows. And I would like to just advocate for doing that. So thanks for your time. I hope you like this talk. And if you have any questions, please let me know.
We have time for some questions. Okay. Thanks, Agriya.
Thanks.